This is a video for how to go about changing the size of a beam, girder, or joist in Autodesk Revit. You will notice in the Revit project I have right in front of us, I have a kind of a framing of a library, and I have a beam right here that is a wide flange beam of W12 by 26. I have a girder that's a size of 18 by 55, and then I have a K-series bar joist with an angled web up here at the top that's an 18K9 size. Now, if I want to change the type of beam based upon the amount of weight acting on it, there's a way that I can change that beam type and size within Revit. And from a previous video, we discussed reactions of beams in a beam analysis in Microsoft Excel or Google Sheets, and we also talked about sizing that beam based upon these calculations, and that's in a sizing a beam video that's also within this playlist. So if I'm going to go back to my beam reactions, just for the sake of discussion, let's just say the beam length is 20, and I'm going to say the load per foot is 1,650 pounds, and automatically we have functions to calculate the reactions and the moments, and I'm going to come back over to moment, bending, and shear, and we have another function in here for us to calculate something known as the bending strength number. Now what we want is we want to find for ourselves a type of beam that gets this just under 0.9 if we can, because we have dead load and live load. They're going to act on that framing. And within this inertia number right here, I want to see if I can get that somewhere near just under 0.9, and the inertia number is 150. The bending shear number is 33.1. Now we're going to go to our steel request and sections table, and we're going to go to I-beams for wide flange steel beam. And again, within beam analysis, this bending strength modulus number is a 33.1. So we're going to go to properties right here, and within plastic modulus, I'm going to scroll down until I get somewhere near 33.1, and you'll see that we're within the 12 kind of area here, and within Revit we had that 12 size within this area here, and I can tell I got a 16 by 40, I got an 18 by 55. We could switch this away from this 12 size to something else if we wish. We're trying to find the lightest beam that we can that meets these requirements, so we could scroll down a little bit, and let's see within the 10s, do I have anything that's near that number? I see I got 170 here, so here I got 150. If I go to 170, it goes down to significantly under the 0.9 that we need, and we can stay at 33.1 in this case. So we have 33.1. I see 36 right here, so a 10 by 30 beam could work. I have 36.6 over here. That's under, that's right at that 33.1 is under 36, so that would work. And then we have 170 right here, and if I come over to beam analysis, throw in that 170, it definitely meets the maximum deflection due to design load requirements because it's under 0.9. So come back to our wide flange beam again. We're going to try to find a W10 by 30. We're going to go to Revit. And again, I don't have that in here, so we're going to go to the Insert tab at the top, and we're going to go to Load Family. And when we go to Load Family, I'm going to go to my libraries and go to my English Imperial Library. I will have a link to a place to download these libraries in the info section of this video. Then I'm going to scroll down until I see structural framing. And I'm going to go to steel. And I'm going to scroll all the way down until I see wide flange. I'm going to double click. And when I go to wide flange, you're going to get this brand new toolbar pop up. Let's go back to here. And we said 10 by 30. I'm going to scroll down until I see W10 by 30. W10 by 30, we have it right here. This right here will give us all of the thickness of the web, all the depth, all the area. And we're going to say OK. We're going to go ahead and load it, say overwrite the existing version. And now we will see that if I click on this beam over here in my properties menu, it's going to give me this as an option. There's my 10 by 30. I can hold down on the control key and select multiple beams and change all of them should I need to. Notice that I'm holding down the control key and I'm going to select each one of these beams. It doesn't like that one that I took over here, does it? It picked that one multiple times. It says that's an array, so it's not going to like that. We're going to stay away from that array, and I'm just going to pick on just these specific beams, and we're going to go to 10 by 30, and they're all going to adjust to a little bit lighter of size. Now I would need to change the size of my beam should I say that I miscalculated the amount of weight acting here. So if I said, actually it's going to be, 2,000, that's obviously going to change this number to a different number, and we would have to go back and try to find this inertia number to get that below 0.9. Again, which would take us back to our spreadsheet and along over here, what beam can we find that meets this requirement that keeps it below the deflection here. So this is how we go about sizing those beams. And again, the cool part about Revit is all these things are loaded. And just from the same spreadsheet that we looked at, we were sizing the beam based upon section modulus and all that. All of this is sitting in here for you to choose the type of beam you want. And we have all the area in square feet. We have all of that depth information, and we can go back and plug all of that into area, depth, and thickness, which will help us to adjust our shear strength limit and our other shear strength calculations as we move through calculating beam types and designing them. So this has been a video for how to go about changing a beam type within Autodesk Revit based upon load calculations and beam design calculations.